In this section, we're going to be talking about the rock record, and specifically about the geologic timescale, which is the record of all Earth's history in what scientists think is about 4.6 billion years of time. And um, in the layers of rocks of the Earth, there's different pieces of information like fossils that show us what animals lived here, or there's rock formations that show us what was happening geologically at that time. And so, the purpose that scientists have in organizing this into a geologic timescale is to give us the history of what is known about what was on Earth. And of course, there's plenty of gaps, but there are some things that they can see at some point were here. So, as you study this, remember the idea of uniformitarianism. And what that is it's the idea that processes that are here now, scientists kind of make assumptions that those same processes were happening a long time ago. For example, erosion. Erosion happens now, and they assume that, things eroded like they did before. That volcanoes kind of suck up and burn up rock from deep within the earth and spew it out. And that was probably a similar process to what happened a long time ago. So that's one assumption, and it could be incorrect, but it's probably, the idea of deposition, like sediment being deposited and kind of compacting and forming rock. It's kind of safe in some ways to assume that maybe those same processes happened throughout Earth's history. So in the geologic timescale, this is a picture of it, and it's not my favorite picture of it just because it's so compact. But basically, with the geologic time scale, it's broken into different units of time. So the main units that it's broken down into are eons, eras, so like eons here, eras, periods, and epochs. And eons are the biggest units of time, and specifically, the first three eons make up what is called the whole Precambrian. So these three eons make up the Precambrian, which is just like what we know the least about, because it was so long ago, and it was when the earth was just forming, just becoming barely hospitable to life. Very simple life forms came about, and then there was a few, like, well, not a few, there was plenty of soft-bodied, probably, organisms, but it's hard because since they had soft bodies, they're not preserved in fossils very well. So there's a little bit of evidence of it, but not as much as what you would expect. And because that rock is the oldest, so it's been through the most erosion and deposition and um, plate tectonic movement, it's just all kind of been disturbed. So it's not a very clear fossil record anymore. At the very end of the Precambrian, there were the first hard-bodied organisms, and by hard bodies it means it had some kind of hard part that did preserve in fossils, like bones or teeth or shells or scales. So basically, the end of the Precambrian is kind of marked with the beginning of kind of a good fossil record, which brings me to another point, is that a lot of these time periods, and I shouldn't just say time periods because I think it makes you think of just the periods, but these units of time are often marked by a large mass extinction that happens. So something that's pretty widespread and was all over the earth dies all at once, or a lot of different species die all at once, and it's pretty obvious to see that in the fossil record. And so if there's a large die-off, then it's easy to start basically a new unit of time. So the next shortest one after an eon is an era. And a lot of these eras you have heard of before, like the Cenozoic, the Mesozoic, the Paleozoic. You've heard of these eras before. And eras are uh, generally like tens to hundreds of millions of years of time. Um, and basically a lot of eras are named after the fossils that scientists find present at the time. So right now we are in the Cenozoic era, which means recent life. And scientists obviously know the most about the Cenozoic era. Why? Because it's recent. It's right now. So even the things that are a few thousand years old, the fossils are still good. The rock record is still somewhat intact. So it's easy to find out information. There's just the least damage, and the fossils and rocks that are there are also not buried very deep. So then after eras, um, eras are further broken down into periods, and periods are usually named for whatever wherever they were geographically first discovered. So, like your book gives the example of one that was, first discovered in Australia, but then they could see it in other places, but then it got an Australian name. So, periods are usually tens of millions of years long. And of course, you recognize some of these famous names like the Cretaceous or Jurassic or Triassic. Those are some famous, well known names that you probably know. And then further, the units of time are broken down into epochs, and some of the epochs are like the Miocene or the Eocene, and epochs are just like a lot shorter, maybe thousands of years to a few million years. They're just the smallest division of time. And then, like I said, here's some cool fossils that you can look at in here, but most of these units of time are marked by mass extinctions. That's where like lots of organisms that are spread out over the earth die in a relatively short period of time. So things died really quickly. And sometimes scientists can figure out why. They can see volcanic activity or otherwise, and they can figure it out. Some is still a mystery, but they can see that there was a massive die off and then things changed. So, and then your book gives this great example that at the end of the Paleozoic era, 95% of marine organisms become extinct. So they had 95% of all ocean water organisms die. Okay, so that's it for now on this, and we will move to the next section.